All right. Well, I hope you folks are having a good day. You had yourself a good weekend. Just a couple of announcements before we go ahead and get started. Today's going to be a really easy day because the majority of first periods still had to take their test today because they were out on Friday. We're going to have a really, really short lesson. I just want to go ahead and introduce the trig identities that we're going to be talking about as part of our next unit. This is going to be verifying, simplifying, and manipulating expressions and equations that contain these identities. So, hello. Yes. Okay, so the more familiar and comfortable you are with these particular identities, the easier the upcoming lessons and therefore hopefully the homework and quizzes and tests are going to be coming up. But just a few things. After we do that today, I'm going to pass back your tests. Let's take a look at them, and then we'll talk about any questions you might have. So for the majority of this week, we're just going to be talking about trig identities, and hopefully definitely by Wednesday, Thursday, we'll start looking at our first expressions and our first big problems that we'll be simplifying. But on Friday, because it's the last day before Thanksgiving break, we have to go ahead and do a writing sample every 9 weeks, and I know everybody's super excited about that. So you remember how we did one in the first 9 weeks where you had the rubric on one side, you had the lines on the other, you wrote? Okay. We're going to be doing that on Friday, so we'll probably take our SEL on Thursday at the end of class just because of that. That's pretty much all we got going on this week. What's that? So it'll be like last time? Yep, I'll just give you a problem. In fact, I'll go ahead and tell you it's a composition. You'll just go ahead and solve it and just kind of verbalize your thought process. So hopefully it should be a really good, easy grade. Okay, paid. Friday is not a half day. Friday is a normal day. Yep, only I believe it's the 16th and 17th is when we have our half days. Let me take a look at the calendar real quick. Yep, 16th and 17th. Okay. Yep. So when we come back from Thanksgiving break, we'll have ourselves 3 weeks until break again. All right. So let's go ahead and get started. Okay, so here are the identities we're going to be looking at for this next unit. So this is building towards our next big item. We want to be able to solve trigonometric equations. And in order to do that, we need to be very familiar with these identities. And there are a lot of identities, even more than this, that we're going to go ahead and go over. But these identities are going to cover the next 2 lessons. So they're broken down into 5 categories here. We have the reciprocals, ratio quotient, Pythagorean, even odd, and cofunction. And you'll notice I already put a star by Pythagorean because in my personal opinion, I think those are going to be the most important. They're definitely the ones that show up, I think, the most consistently. So we'll be talking about those tomorrow, but let's just go ahead and get started with the reciprocals. There are 6 of them, and let's start with the trig functions that we're already familiar with. Sine, cosine, and tangent. Okay. Now, as we go through these identities and problems, you'll notice the variable itself is going to change. It may not be theta. They could change it to x, alpha, beta, whatever it is we're going to use, but it doesn't change the identity. The identity is still going to be the same even if the variable changes. Okay, so that doesn't affect it at all. So we already know that the reciprocal of sine is what? What trig function? Cosecant. So we have an identity here that shows that. I can rewrite sine of theta as 1 over cosecant of theta. Okay. And then I can do the same thing for each of the other trig functions. We know the reciprocal of cosine is secant, so I can rewrite that as 1 over secant of theta. Tangent and cotangent are going to be reciprocal, so I can say tangent of theta equals 1 over cotangent of theta. And then we're going to be able to do the exact same thing with the remaining 3 trig functions. So let me go ahead and write those out. Cosecant of theta, secant of theta, and cotangent of theta. All right, so if sine of theta equals 1 over cosecant of theta, what do you think cosecant of theta equals? 1 over sine theta. There you go. Okay, secant of theta is going to be 1 over cosine of theta. And to finish it up, cotangent theta is going to be 1 over tangent of theta. All right. So there we go. Those are the 6 basic reciprocal trig identities that we're going to start with. Now, for each of these categories, I want to go ahead and take at least one of the identities and go ahead and prove it to you. I want to derive it. I'm not going to do that for all of these, because if I do one of these, you're going to see how the others can easily be proven. I'm thinking about closing that window. Those birds are really loud today. I'm going to be interested to see if they can hear that on the recorder, but there we go. There we go. Okay, so let's see here. Justin, choose one of those 6 identities. Sine. So sine of theta equals 1 over cosecant of theta. I want to go ahead and prove this one. All right, so first off, let me go ahead and rewrite it. So sine of theta is going to equal 1 over cosecant of theta. Now, we already know at this point that the trig functions, we can rewrite them as ratios involving x, y, and r. So to go ahead and prove this identity, we're going to replace the trig function with its ratio. What is sine's ratio? It's y over r. So I'm going to say sine of theta, y over r, is equal to 1 over cosecant of theta. Bren, what's that? What is cosecant's ratio? R over what? R over y. Perfect. So you'll notice here, I've got a fraction down in the denominator, so when I divide by a fraction, what do? I multiply by the reciprocal. Okay, so I'm going to say that x, what am I saying that? It's Monday. I'm going to say that y over r, that is not what I wanted. Okay, so I want y over r is equal to 1 times, and then I'll flip the fraction, y over r. So this implies that y over r does indeed equal y over r. So this is a legitimate property. Okay. So now you see how the other ones can be done in a similar fashion. Now, this right here is a proof. It's a derivation. So when you hear that word proof, you don't want to immediately be intimidated, because truth, there are a lot of really large proofs out there, but there are just as many quick and simple little proofs like this. Now, if anybody were to take a look at our work, we would want to go ahead and send along the message that we're done with the proof. We've accomplished what we set out to do. And there's a variety of ways to do that. What I like to do is put the letters QED at the end of it. That means quite enough done. Okay. And there are different ways to go ahead and signify that. The QED signifies to the reader that that's the end of the proof. Okay. It's not wrong, but you're kind of just leaving it open-ended. So you need to go ahead and kind of finalize that. Almost like a stamp of approval. There you go. Okay. All right, so there are the 6 reciprocal identities. That's pretty basic. Okay. Now, there are only 2 ratio or quotient identities. So those 2 words can be used interchangeably. Sometimes I'll say ratio, sometimes I'll say quotient, but there's only 2 of them. They are tangent of theta and cotangent of theta. Now, we've actually seen these before. Admittedly, it has been a while, but think back to the lesson where I first introduced you to the graphs of tangent and cotangent. You remember how I rewrote them in terms of sine and cosine, and I used that graph to help us find the asymptotes? Well, that was basically a preview of what we're seeing exactly right here. So tangent of theta, I can rewrite that as sine of theta over cosine of theta. That's one of my 2 ratio or quotient identities. Now remember, tangent and cotangent are reciprocals, so if tangent equals sine over cosine, what's cotangent equal? It's going to equal cosine over sine. Perfect. Okay, and there are my 2 identities. Okay, Edward, choose one. The second one. Okay, so I want to prove that cotangent of theta equals cosine of theta over sine of theta. All right, so I already have a little bit of room here. Now I'm going to use the same strategy that I did in the previous category. I'm going to replace each of the trig functions with their ratios. Okay, so what was cotangent of theta? Okay, so that is not y over x. So x over y equals, then I got this big fraction over here. What was cosine? X over r, and sine of theta. Y over r. There we go. Now we just want to go ahead and perform a little bit of algebra to show that this is a valid property. I'm dividing by y over r, so that would be the same as taking the numerator, x over r, and multiplying by the reciprocal, r over y. And you'll notice what happens. The r's cancel, so indeed x over y does equal x over y. What's that? And then quite enough done. That's right. QED. Quite enough done. Yeah, quite enough done. QED. We have peculiar ways of doing things in mathematics. There are symbols that you can use if you don't want to go ahead and write QED. Like, for example, you could do one of these two. You could go ahead and draw yourself a little box. Some people like to go ahead and shade in the entire box. That signifies the end of the proof. Or some people will just go ahead and shade in half of the box. There's a whole variety of ways to let the reader know that the proof is over. I like QED. That's the one I've always used. Oh, I mean, any of them will work. These are just three different ways. Yeah, it's not that one is better than the other. They're just different ways to end the proof. Okay. All right. And like I said, right there, that's the introduction that I wanted to go ahead and do today. So the lesson is over, but I will encourage you, okay, whenever you have the option, write these down. The more you write them down, the more familiar, the more comfortable you're going to become with them. You're going to be able to see and do more when we get to the problems, and you'll start to see, what that means in just a couple of days. But I wanted to go ahead and make sure that everybody has a full copy starting out the lesson. All right, so what I want to go ahead and do now is pass back your tests, and then we'll talk about any questions you might have, starting with Eric. There you go, sir. Then I've got Edward. Okay, Donovan. Okay. And then Bryn. There you go. Ricky. Elliot. Justin. Campbell. Lindsay. Cynthia. Let's see, Zeke. Kushal. Then we have Peyton. Amna. Chris. Anthony. Okay, I got Towns. And I have Brand. Okay. Okay, so now I'm not going to record myself as we talk through the exam, but I do want to go ahead and say while I'm still recording, if you want to retake this, if you scored below an 80, you can definitely retake. You have to have one of the two graphing assignments done, because remember we had graphing sine and cosine, and we had graphing the other four. As long as you have one of those done and the homework for the inverse trig functions, then you can go ahead and retake. Remember, the deadline is by Thursday morning at 8:05.